Hi, welcome to Bits and IT Bits and Bots. A few days ago, I made a video on static routing. Static routing is a good way to route between the different sites. But what happens is once you have too many routers or they're uh, become a lot of different routes to different networks. It becomes a nightmare for the system administrator or network administrator. So in that case, as I mentioned before, dynamic routing is probably the better way to go. What happens with the dynamic routing is the routing protocol itself takes care of different routing tables. So it just creates different routes. Once you provide it different networks it's connected to. So it's relatively a simple way, but only problem is once you have too many sites, um, it becomes a little cumbersome to manage. And here, when we take a look at it, we have area 1, area 2, and area 0. So once you implement dynamic routing on all these areas, it becomes a little complicated. So what we'll do is instead of doing that kind of troubleshooting, we'll start with a smaller network. We will just take the central area, and we'll call it area 0. So we are going to ignore area 1 and area 2 for right now. Maybe in later videos we'll take care of that. So I've already configured IPAs on all those routers and the computers, and we will just get to configuring the dynamic routing. So there are different dynamic routing protocols, but this video is on OSPF, Open Shortest Path First. It's a dynamic routing protocol, and it takes care of these routes. So what I've done is I've already configured OSPF on this router and this one. So because they are pretty similar, this one is similar to that one and this one is similar to this one. So we'll just configure these two, and then we'll see are we able to get to the other network or not. So right now, if we try to ping from this network to, say, one ping 192.168.1, and now this is we're pinging from this network to that network, from 10 1.1.0 to 192.168.1.0. So let's see what happens. So it's not working. So why it's not working? Because it says destination host unreachable. Why it's saying that? Let's see. If we go to this router, and now we are looking at the routing table of this router. So we can see that this router knows 172.16.3 network. It's directly connected. 172.16.4 network, it's directly connected. And then 10.1.1 network, again it's directly connected. So this router has no idea how to get to this router. So similar problem as we had before with static routing, but what we can do instead of a static routing, we can configure this with OSPF, which is a dynamic routing protocol. So let's get into this router. So now what we do first is we go to config mode, that is configuration mode from terminal, right? And next uh, we okay, here what I'm saying to the router is I'm going for routing protocol, and the protocol will be OSPF. and and the this one number one is process ID. It's local to the router. It doesn't go anywhere else on the network. It stays with this network, and it creates all the information about OSPF routing locally on one process ID. So we can choose any process ID from 1 to 65,535. So here we just go with 1. Okay, now so we have to tell this router which networks it's connected with. So let's see. First of all, it's connected with, say, network 10.1.1.0. Now, once we enter this information, then it says OSPF wildcard bits. Now, OSPF wildcard bits is a fancy name, but all it means is you just subtract the subnet mask from 255, 255, 255, 255. So this should be, in this case, because it's a 24 bit network, so that will be this one right here. So let's say 0.0.0 dot what 255. Okay, now we earlier discussed that we are going to just select this area. This is area 0, and this is area 1, this is area 2. But in this video we just taking care of our smaller network, and we not worrying about combining area 2 and area 1 with this network. We'll do that in later videos. So let's just enter area 0 here, right? And again, what's the other network connected? uh, Network 172.116.4.0. Now look at this here. The bits used for the network is 30 bits. So this subnet, this wildcard will be 0.0.0.3, because all 255s minus this is the subnet mask for this network, right? So 255, 255, 255, 252. So 0.0.0.3, right? So let's enter 0 0 0 3, and same area 0, right? So we are just in this one area. We are just considering that area. The other one, network. Now this router is connected with 3 networks: this network, this network, and this network. We entered this one, and now we are entering this one, right? So all we change here is, instead of 4, we just change 1 bit here and no byte here, so we just enter this information and here we go. Now, so let's go to the other router. Like I said before, I have already configured this router and this router because this one is very similar to this one and this one is very similar to this one. Just to save some time, I've already configured this. So let's go into this one. Go to configuration mode and so here first we tell the router that we're using routing protocol which is OSPF, and the process ID will be same one because it's local. We don't have to change it. It's local to that same router, so we don't have to change it, right? Right. And the network it's connected to. Now look at this. We're saying that we are not considering area 1. So all this router, all the networks this router is connected with is this one and this one, right? So let's see, 172.16.1.0 and wildcard will be 0.0.0.3 and area will be area 0, right? Okay, now again the other network it's connected with is, we just change from yeah, see this message just popped up. That means it made a link between these two routers, so they are exchanging the routing information, so they are like neighbors now, right? So this one was 4 and the wildcard remains the same and area remains the same, right? So we do write. That means we're writing and this message popped up again. That means it's making a neighborhood with both of these routers, this router and that router. So let's see now, if we take a just look at see, let's see the difference. Before, when we looked at the route, only thing we could see was the connected network and local network. We didn't have those O's before. O means OSPF. So OSPF created some routes, and now because of OSPF, it can see this network also, and it can see um, this network also. This router can see this network also, right? So I'm sorry, this can see this network, and at the same time it can see this network also. So let's now do a write here again just to make sure, and and now once we've done this, OSPF has propagated all the routes that we just saw in the routing table. That means this connectivity should be working, right? So now we should be able to ping. Now before that we were getting destination host unreachable, so we shouldn't shouldn't get that message anymore. We should be able to ping it, right? So first of all, it's pinging okay. Now second thing, we check just to be sure that it's working all the way from here to here and all around. So we go there. We just, because it's this one is a web server, so let's do 10.1.1 dot 10. I think the IP is 10.1.1.10. So let's open that web server. It's working just fine, and we can get to the web server. So everything is working all around. It's those dynamic routing protocols can be simple, but when as the area gets bigger, more and more routers, maybe hundreds, maybe thousands, so it gets a little cumbersome. So there's a lot of troubleshooting involved once you add these areas. So just be mindful of that. There is a lot more learning involved here. Thank you so much. And this is how we configure OSPF for a smaller network, and maybe in future we'll do something about bigger larger networks also. So thank you.